Hello, my name is Matthew Engstrom, and I want to thank you for watching this video about Sciammba gardens. One of the biggest challenges we all face as a result of climate change is the drying and in some cases actual desertification of areas that right now are used for agriculture. This issue is causing a host of problems up to and including the total loss of farmland that can no longer support crops with the amount of water it receives. Some other areas are able to cling on to their ability to grow crops, but only by heavily depending on the use of groundwater, often from deep beneath the earth, but in many areas these too are running dry. There are towns in the US that have had their elevations above sea level reduced by dozens of feet because so much water has been pumped out of the aquifers that they're sitting on in order to support nearby agricultural production. This photo here shows the dropping of the San Joaquin Valley in California, and it is several decades old. And so, some farmers are facing drying conditions, but are able to hold on to their farms, though in an unsustainable way. Once those wells are dry, they are dry, because the rainwater is not replenishing them fast enough to keep up with the demand. And, of course, those farmers unlucky enough not to have access to these groundwater reserves to begin with have no options at all and must look elsewhere, as must the consumers that they used to sell their produce to. Plus, we must remember that the global population continues to climb. Here's a chart showing global population over time for the last 12,000 years. As you can see, we're living in a time period when there are many, many more people than there have ever been before, so we really cannot afford to be losing arable land to climate change right now. Not only that, but look at this map showing the different nations of the world according to a color coding scheme intended to display each country's population growth rate. As you can see, much of the population growth that is happening right now is happening in what is known as either the global south or the global middle, which is where the countries worst affected by climate change are located. And in order to deal with this problem, where the arable land that used to provide for people is becoming too dry to produce crops, many times people in these countries will turn to the destruction of some of the world's few remaining forests in order to create land for agriculture, which is another related problem that is growing out of control. Well, I have the solution for just this issue, the loss of agricultural spaces and wildlife habitat as a result of climate change and population growth, and I call them Sciammba gardens. Inspired by some of the world's most successful, long-term, and sustainable methods and technology from civilizations all over the world, these gardens are designed to do nothing less than unite all of humanity behind the cooperative management of our world's most precious natural resources. So what are these Sciammba gardens? Well, the name is actually an acronym for Smart, Classically Inspired, Aquatic, and Molecular Model-Based Agriculture. So why don't we just start by going through the acronym, beginning with the letter S for SMART. I grew up just outside of a town named Roseburg in a fairly rural part of southwestern Oregon. This part of Oregon is historically best known for lumber production, but there are farms here too, with vineyards becoming more and more popular in the region in the past couple of decades. When I was younger, I worked on some of these operations for summer jobs, picking fruit, pruning parts of plants, and checking and packing fruit into clamshells. And they are all fairly demanding jobs. Not only that, but many of the positions are only seasonal and offer no benefits of any kind. And there are even special laws regulating agricultural work in many areas that make it so you're ineligible for things like overtime pay or a minimum wage, to name a couple of examples. According to the National Farm Workers Registry's website, farm workers are among the poorest workers in the U.S. Hazardous conditions are routine and include pesticide exposure, heat stress, lack of shade, and inadequate clean drinking water. Child farm workers risk their safety, health, and education working in the fields because their parents can't earn adequate wages to support a family. Agricultural work is hard work. In order to feed the country, an estimated 2 million farm workers labor in fields and on ranches across the U.S. They handpick the vast majority of fruit and vegetable crops produced here. Farm workers are the backbone of our $200 billion agricultural industry. As a result of this, there are very few adult Americans who want to do this work. And so the agricultural industry, especially in areas that produce lots of fruits and vegetables, it is staffed largely by illegal immigrants and others who are willing to put up with the demanding conditions on offer. And this isn't an industry that most people want to stick around with, so as soon as the illegal immigrant labor that does much of the work gets a different opportunity, they are gone, and more illegal immigrants are recruited for the positions, creating both a constant need and flow of illegal labor over our borders. This both strengthens the positions of people like the coyotes and drug cartels that benefit from the horrific and thriving trade in human trafficking through Mexico, and ensures that jobs in the agricultural sector are never made to be desirable for a normal American adult. But there are other kinds of agriculture that don't require a large pool of desperate, exploitable labor to keep functioning. In many parts of the Midwest, for example, where they predominantly grow corn and soybeans, the work has been automated to the point where labor can be done by farmers with much more comfortable conditions than are faced by migrant workers today. And automation is coming to the produce industry too. This model here is an Oxbow Model 8040 blueberry harvester. I know that one of the farms that I used to work on, for example, they would use a mix of automated and hand picking for their berries. And there are some trends towards automation in the hothouse industry as well, with the plants being fed by a hydroponic solution through systems that circulated around the facilities, like in the current day hothouse system that you see depicted here. Well, my goal with the Sciammba gardens will be to take these trends even further. The Sciammba gardens, which are in some ways similar to an interconnected floating hothouse system, will be able to provide jobs that Americans will actually want to do. Unlike working in the fields, working in the gardens will be in comfortable conditions, not with the heat of the sun beating down on people, not without bathrooms or running water nearby. Instead, there will be standard workers' facilities and regular breaks. The workers don't need to bend over all day. They will be on platforms that are raised or lowered on the sides of the growing rows, depending on the height of the work that they are doing. And the gardens will be so standardized and interchangeable that we will have new opportunities not available in the industry right now, such as docking them in work sheds where the automated systems can perform simpler functions, running down standardized railing systems featured in some of the gardens. So that is what the S for SMART part of the acronym means. It stands for the idea that Sciammba garden systems will take industry trends towards automation even further by offering new levels of standardization and a garden platform capable of easily floating from one location to another. Okay, so the next two letters are CI, standing for classically inspired. So what do they mean? I studied history in college. I have loved studying it ever since, and this interest has inspired much about the idea that you're going to hear. So why is this an important thing? Well, one thing that I want to do is basically to piggyback off of ideas that have been established as sustainable for long periods of time. And I'm not the only one thinking this way. This picture is from Bangladesh, where floating garden agriculture also has a history that is being revived in South Asia right now. The 20th century saw a lot of major agricultural projects, and many of them were truly disastrous. The Great Leap Forward in China, for example, is estimated to have killed between 30 to 55 million Chinese people during the second five-year plan. The Soviet Union had a series of famines early in its history as well, which are also estimated to have killed people numbering in the millions. I actually wrote a research paper once on one of the key architects of the Soviet disasters, a man named Trofim Lysenko, who was largely responsible for a horrible purge of the agronomist and biologist establishment in the former USSR, and a theory of evolution referred to as Lysenkoism, that drew from Lamarckism and rejected the field of genetics that was being developed in the West. His theories and policies, which were adopted in China under Mao Zedong's government as well, caused enormous suffering and are certainly a cautionary tale for anyone trying to change an agricultural system today. And yet there are also many, many counterexamples as well. There are many times in our history when people actually have come up with some new invention, a new kind of plow, a new tractor implement, or something as simple as barbed wire, or this horse harness from Wikipedia that has changed the way that we raise our food forever. And so I want to base my idea on the wisdom of people that have come before us and draw from ideas that have been proven to work rather than try and start from square one. Take the Aztecs, for example, with their Chinampa system. The Aztecs' capital was located in the Valley of Mexico, which is in an endorheic basin, meaning that water flowing into it has no way of escaping other than by evaporation. As a result of this, lakes in endorheic basins, like the Valley of Mexico, tend to develop a saline character because the rivers that feed the lakes carry a small amount of salt in their water, and this salt is unable to evaporate away with the water it comes in with, so it accumulates in the lake water over time. Well, the Aztecs dealt with this issue in a couple of ways. One of the ways was through the construction of causeways. Some of these causeways segregated out small portions of the lake near where the lake was fed by a fresh water stream. This would keep the water in these portions a little higher than the water in the bordering portions, and so the flow of the water would go from the fresh stream to the segregated portion, and then from the segregated portion to the bordering brackish lake areas, and the flow back the other way was minimized. And these segregated portions were the areas that they built their chinampas on. The chinampas were constructed by making a kind of cage from intertwined sticks, branches, and reeds, and then this would be filled with earth and old vegetation until there was a layer that protruded above the level of the lake. Sometimes mislabeled as floating islands, as are used by the Uru people who live on Lake Titicaca here, the Chinampa were instead a kind of artificial island that contains lots of lake water soaked up into the soil that has been placed inside. The Chinampas were enormously productive for the Aztecs, allowing them to support a population in the capital they fed that is estimated to have been as large as any city in Europe at the time, and they are still around to this day. Or think about the step wells that were used in Western India. These beautiful structures were first cut out of the rocks in India beginning nearly 2 millennia ago. Their purpose was to store water and also to act as a cool meeting place on hot days. Many of them were also covered, technically making them big cisterns too. Those that weren't, or at least had the water down in a bit of a recession in the ground, reducing the amount of evaporation that they would suffer by blocking the sun from the water's surface with just their sides alone for part of the day. And the step wells provided at least a bit of a windbreak too, even when the sun was shining more or less directly overhead, which provided additional protection from evaporation. These and systems like them can be found in India to this day. Consider next the Anden, which is the Spanish word for platforms, the root word of the name of the mountain chain that they are found in, the Andes, and a kind of advanced terracing system developed by the Inca. There is liquid water to be found way up high in the Andes Mountains from things like melting snow and precipitation. It is just very hard to use because it doesn't stick around for very long on the steep mountain slopes. And so when there's a bit of snow melt or a big rain, there are streams that develop and take the water down the Andes slopes, and they can have a lot of water when they do so. It's just that they don't last for that long before the water's been conveyed and they dry up. Compounding this issue, where the water is delivered in a very sporadic way, there is also a big problem with the temperature, because the Andes can get very, very cold at night, even though they're right by the equator. The slopes that the Anden were constructed on were covered in a blanket of grass and sedges before they were developed, and this layer effectively shaded the soil, not allowing much sunlight to penetrate through its cover. And even when the vegetation is removed, soil itself is not very good at storing heat and acted kind of like a layer of insulation that didn't allow the sun's thermal energy to penetrate very far down. The Inca solved this problem by facing their Anden with a wall of massive stones that were relatively excellent at absorbing thermal energy from sunlight and storing it too. These huge rocks would sit in the sun, soaking up heat like a driveway on a hot summer's day, storing it deep within their cores, and would then release this heat as the temperature in the air dropped overnight, preventing frosts and allowing the Inca to grow their crops at higher elevations than would otherwise have been possible. They dug canals and irrigation channels to manage the intermittent waters, and they directed them to the Anden, which accepted the water with a special stratified design with layers of different types and sizes of rocks, sand, and soil. This design allowed the top soil layer to soak up moisture, but not to the point of getting waterlogged, which might cause structural problems that would weaken the terraces, because it was able to drain into the sand and rock layers that weren't susceptible to waterlogging. And there are many, many more examples of how the different civilizations of the world have managed their water resources. In fact, the communal management of freshwater resources might be the whole reason that we as humans ever created civilization to begin with. All of the 3 earliest centers for civilized life, the Mesopotamians, the Egyptians, and the Indus Valley civilization, developed along the banks of the major regional rivers in their areas, the Tigris and Euphrates, the Nile, and the Indus, obviously. Big rivers like these could be both a blessing and a curse to these early peoples. Floods were big killers in ancient times, but in a place like Egypt, the river was quite obviously, in contrast with the desolate, arid lands surrounding it, the source of life as well, as dramatically depicted in this screenshot from my computer running Google Earth. And these rivers were quite obviously communal resources as well. One reason for this was that what the people did with the water upstream inevitably affected those living downstream. Another reason was that the projects that people carried out, like irrigation canals, were of a scale that required coordinated communities of people to build, maintain, and operate. Those that were able to join in this communal activity were thus advantaged over those who were not able to, and were able to outcompete them as a result. And this is attested to in the history and myths that we have handed down to us from the region. Egypt's earliest historical figure, the Upper Egyptian king Scorpion, for example, is depicted here as holding a primitive kind of hoe used for opening the irrigation dikes during the yearly flooding of the Nile, and then for working the fields possibly. And in the Mesopotamian Epic of Gilgamesh, a semi-historical work believed to have been built up around the memory of an actual king who ruled during the 3rd dynasty of Ur in the last part of the 3rd millennium BC, Gilgamesh and the people of Uruk rise to power over their regional rival, the city of Kish, after being the first to install irrigation networks around their city. We can't yet decipher the Indus Valley Civilization script, but if we ever do and read their myths, I wouldn't be surprised if Indus Valley River irrigation schemes pop up as one of the major topics of interest in their storytelling too. And this sort of thing didn't just happen in Egypt, Mesopotamia, and the Indus Valley, but in other places where civilization was independently developed as well, such as in Peru, where the Norte Chico civilization was established along the Fortaleza River and in neighboring river valleys. The Chinese, who developed along the banks of the Yellow River, even had a mythology built up around the taming of the river that was based on the semi-mythical Great Yu, a Paul Bunyan-like hero from China's 3 sovereigns and 5 emperors period some 4 millennia ago. Yu managed the work with a system that involved widening choke points and dredging narrows so that the water could more easily flow to the sea in times of flash flooding, and he also created a new network of irrigation canals that were used to direct floodwaters away from the river and out into the surrounding countryside as well. Instead of Babe, the big blue ox, you may or may not, depending on your source, have had a team including giant magical turtles and dragons that assisted him with his efforts, which is always nice. And here is a map of where the Olmec civilization developed in Mesoamerica. As you can see, it matches the trend that we have noticed everywhere else. It's all along the rivers. These riverine settings are the cradles of development for advanced agriculture based on collective irrigation projects, and then the first civilizations shortly thereafter. Here in America, most people are probably more familiar with a version of what is called a Laurentian flood myth, specifically in the story of Noah. The Epic of Gilgamesh, by the way, contains a much earlier version of this myth than is found in the Bible, and is believed by many to have been an important source for the story of Noah directly, bringing us back to the ancient roots of the need to manage important rivers as the basis for some of our most fundamental myths here in modern America as well. And so, as a modern historian, I have become convinced that these big water management and agricultural programs have enormous potential and are in fact at the very heart of civilization itself. Zooming forward a bit in our nation's history, here where I live in America has also been shaped by our management of shared water resources. It's kind of hard to imagine it now, but in colonial and early American history, water-based transportation, especially on the Great Lakes and bigger rivers and man-made canals such as the Erie Canal, was immensely important. And as the American Empire expanded to the west, canal systems were sent out as well, where they were used for both transportation and water delivery too. But the construction of things like canals are only one way that people have had a big impact on the hydrography of our country. Another way that we have had a dramatically huge effect is through our removal of things, namely trees and beavers. Other than human beings, beavers are probably the animal that has the biggest effects on its natural surroundings. Through their creation of beaver dams and ponds, as well as their creation of extensive canal networks measuring up to half a kilometer away from their central ponds, beavers used to have a massive effect on the amount of water found on the American continent. Their removal had enormous consequences that we continue to experience to this day. But it wasn't just killing off all the beaver and draining all of the wetlands that they used to maintain. The arrival of the same European settlers that brought with them the transatlantic fur trade also brought with them the tools and will to follow the trees from the forests along the banks of the nation's rivers. And this also had a massive effect on the hydrography of the country because before this, the trees used to get old and fall in the water, and in large numbers. And this had a major effect because of the creation of log jams, big ones. One of the biggest of them all was the Great Raft, which at its peak was well over 100 miles in length. And so the removal of the beaver and the logging of the forests nearest to the streams, which were also essential for moving the logs downriver, drained a huge amount of surface water from North America and made it a drier place on the whole. But perhaps the biggest way in which people have affected the hydrography of our country is through the creation of large dams and their accompanying reservoirs. Seen here are developments on the Columbia River system. There are many, many arguments for and against how good of an idea the construction of these dams actually was, as there are for the removal of the North American beaver population and the creation of the canals as well. But such things did happen, and they are a part of our nation's history at this point. What are not such an important part of our nation's history are the kinds of agricultural technologies that I started this section describing. We have canals and reservoirs, and we have trapped all the beaver and logged most of the trees in the riverbanks, but where are our versions of things like the Sciammba or the Anden or the step wells? The closest thing that I can think of to these kinds of technologies is something like the modern greenhouse. Greenhouses can trap heat during the day and use it to keep crops warm at night, sort of like the Anden. They can be used with hydroponic systems that foster fast plant growth, sort of like the Sciammba of the Aztec. I can't really think of how they were used to function like a step well so much. I suppose maybe they could contain water tanks, but I do have a few improvements that I think will greatly enhance today's greenhouse technology. And that is where the CI for classically inspired come from. I don't want to try and create some whole new set of ideas from scratch because they suit the needs of my dubious evolutionary theories like Lysenko. I want to draw from the noble traditions that our human ancestors from all over the planet have used in order to thrive in harmony with their natural surroundings for extended periods of time. The notion of modern science might have been foreign to the ancient Aztec, Inca, and Indians, but they certainly did a lot of inventing different things, finding out what did and did not work through trial and error in the field, and then developed methods and techniques based on their empirical observations about what would produce the best results. And they did this for long periods of time. So they might not have called their experiments scientific, but I think that it certainly is very similar. People sometimes mistake the Sciammbas for floating gardens, which is actually not the case, as technically the branches and soil that the people walk on do touch the bottom of the lake and help support their weight against it. They aren't floating. Instead, it's a packed slurry that does touch the bottom, but it does also support your weight above a large volume of lake water soaked up in the soil, so it's just that it's actually touching the bottom. But the Sciammba gardens I want to build, the systems I'm talking about, actually will be floating. Looking at a bunch of them from a distance, however, it would probably be difficult to distinguish between a bunch of Sciammbas and a collection of very basic Sciammba gardens. Most Sciammba gardens, though, will at the very least feature a small hoop house on top of them, so that would be a difference that I suppose you could see from a distance away. Another difference that you could spot, at least in some applications, is that the Sciammba gardens aren't intended to line the shallows near the shores. They're intended to cover massive portions of the lake. In many cases, well over 90% of the lake's surface. And in that way, they will kind of act like massive step wells. What I mean to say here is that a step well is sort of like a huge man-made cistern, some of the biggest I know in the pre-modern world. And what we're going to be doing is basically making a huge cistern out of many of the lakes that we garden, with the Sciammba gardens acting as a kind of lid for the whole system and preventing evaporation. And the location of these gardens on the water bodies will also help us to mimic the Anden by helping us to thermoregulate. Take a look at these little balls that are covering this lake. They're something like pitball balls or big ping pong balls. These balls can actually have a major impact on the water below them because they block sunlight from hitting the water, block wind from sweeping over the water, blanket the water in freezing temperatures, and dramatically reduce the pond's surface area. And all these things can have a big effect on the amount of evaporation that the pond gives off. Well, our Sciammba gardens will do all those things that the balls can do, but they will also be able to take advantage of a useful thermoregulatory effect from being on the water as well. Okay, so the next letter in the acronym is A for aquatic. Well, this one is pretty easy to explain, as most of the gardens are designed to float on bodies of water, and even those that aren't are designed around massive water tanks intended to mimic the effects of being on a pond or a lake. Going back to this image of the balls on the lake, if you squint your eyes, you can almost imagine them as the floating hoop house gardens that I was describing earlier, which would be nice, right? because these balls aren't really all that practical for a wide variety of applications where we would be able to operate Sciammba gardens, such as in areas with a more natural surrounding where wildlife might have more negative interactions with small plastic balls, for example. But with our Sciammba gardens being several orders of magnitude larger, like these hoop houses, this won't be such an issue. As I was pointing out earlier, with the global warming and the increased human demand for water in many areas, we are running straight into a major water crisis. And the technologies that I am talking about can have a massive effect at lowering evaporation rates and thus protecting our remaining water resources. And again, there is also the thermoregulatory benefits that the gardens can take advantage of in ways that the more simple balls simply cannot. Take a look at this map of the globe showing lines of latitude. The Gobi Desert here is at about the same latitude as the Oregon coast here, and yet the weather above the Gobi Desert features some of the most extreme swings between summer highs and winter lows found anywhere in the world, whereas the Oregon coast is famously temperate in climate. The main difference is in the two's locations relative to the global ocean and global weather patterns. Places at the latitudes of the Gobi and the Oregon coast lie under what are known as the westerlies, which are prevailing weather patterns that sweep across the US and China, going from west to east. Coastal Oregon gets its weather from over the Pacific, and the Gobi gets its weather from over Siberia, and ocean is much better at moderating atmospheric temperatures than continental surfaces, so the Oregon coast gets the more moderate climate. Well, the artificial climate that we create inside of our Sciammba gardens on the lakes and ponds will often exist in places with extreme climates, but will be featuring temperatures moderated by the temperatures of the bodies of water that they cover. So during the heat of the summer, we will get a nice cooling effect from the shaded lakes the gardens cover. Alright, so the next two letters are a pair of M's, standing for molecular model. These two parts of the acronym actually apply best to some of the most advanced maritime Sciammba gardens, which are actually significantly different than the simpler freshwater systems that I will be starting with, and I won't be getting to the marine systems for quite a while. But take a look at this thing here. It's called a Vesper model. This is one of the molecule methane, which is shown as a perfectly regular tetrahedral shape static on the page. And yet we know that methane molecules in reality are nothing like this, except perhaps near 0 degrees Kelvin. In room temperature conditions, though, the methane molecules are highly energized, with their electrons driving motions that change the bonding angles and the bonding lengths, and have them bouncing against other molecules all around the atmosphere. Now take a look at this molecule, ethylene, a famous monomer. As you can see, it is a closely related hydrocarbon to the methane molecule we just observed. And this is polyethylene, which is made from reacting a bunch of ethylene together and is a polymer. Polymers are molecules found all over nature and in the field of plastics and other parts of organic chemistry that are composed of large numbers of repeated monomer groups. Well, these polymers are all over the ocean in the form of the plastics that have formed the famous Pacific trash vortex in the middle of the ocean, among other things. Thinking about this, I had the idea for a massive multi-hulled ship-like platform that would have a large number of separate hulls, kind of like a giant molecular model, that were all joined together with a system that would try and keep them at their ideal bonding lengths and distances without ever actually being able to get a perfectly stable static arrangement because of the wave action, but trying to, and in so doing, achieving an acceptable, stable result that would also allow the system to ride upon the waves and flex with them. One characteristic that polymers have is that they are massive, many times more massive than almost any other molecule because they are composed of so many repeating units. And ours will be so big that they will all have an aggregate effect on the surface of the water too. This will be even more pronounced on some of the lakes that we work with than on the ocean. Take the Aral Sea, for example. It used to be so big that it featured significant wind-driven action, during storms especially. Well, I'm going to be proposing a system that covers over 90% of the lake's surface as we resurrect the lake. And even though, like I said, the systems that I recommend for use on lakes are much less heavily built than the maritime systems, having that much surface area covered is going to have a major effect on the wave action on the lake, dramatically calming the waters compared to what they would look like without the cover. Okay, and so that is what is meant by molecular model based. The gardens are supposed to be sort of like monomers, mass-produced in repeatable units intended to function in specific arrangements with their bonding neighbors, where they all enhance the stability of the gardens surrounding them and try to act like molecules in our models from chemistry with their prescribed ideal low-energy bonding angles and lengths. And that's what brings us to the last two letters, B and A, for based agriculture. These two are pretty easy, right? Of all the things that I've mentioned thus far, the desire to move towards a smarter agricultural system, one based on more sensors and automated robotics and less on exploited human labor, being the first one I covered. These gardens are also based on the lessons from the past, rejecting the pseudoscience of the 20th century communists while embracing the time-tested and empirically based systems like the Sciammba, the Inden, and the step-well cistern. And they are based on the ideas taken from molecular modeling, specifically that of polymers. And all of these influences impart on the Sciammba gardens special abilities and features that are important to the functioning of the system. I am convinced that these systems could help us deal with the extraordinarily scary issues I started with in this introduction, namely the desertification of large portions of formerly productive farmland as a result of global warming and increased human demand on global water systems. So thank you for taking your time to watch part one of this series. In the next section, part two, I will be exploring how a real-life system might function on the Colorado River system that drains much of our nation's southwest. I hope that you will join me.